Hello everybody and welcome to my channel Easy Maths. In today's tutorial we will be learning about how to find square roots of numbers, or should I say it in a more specific way, we will find out how to find square roots of positive integers. Now before we move on to the actual topic of how to find square roots, there are certain things which we should know. The first thing which we must know is a perfect square. That is, we must know what is a perfect square. Now, to understand what is a perfect square, let's take a very simple example. Say 4 times 4 equals 16. Now we can say that 16 is a perfect square because it is obtained by multiplying a number to itself. So whichever numbers are obtained by multiplying a number to itself are called perfect squares. Let's take another example. 5 times 5, that gives us 25. So 25 is also a perfect square because 5 when multiplied with itself gives 25. But if I say 5 times 4, that is 20. Now 20 is not a perfect square because this is not obtained by multiplying 5 with itself. So 20 is not a perfect square. So we will have to concentrate in this tutorial only on these kinds of numbers which are called perfect squares. Now that we know what are perfect squares, so 16 is a perfect square and the square root of 16 is 4. So the square root of a number is that number which when multiplied by itself gives that number. Now trying to remember these definitions might be a bit difficult for you all, so it's better you understand these concepts through these examples. Like 16 is a perfect square, so the square root of 16 is 4. 25 is a perfect square, so the square root of 25 is 5. Let's take another example. Say 12 times 12 equals 144. So with using the same concept, we can say that 144 is a perfect square because it is obtained by multiplying 12 with itself. So the square root of 144 is 12. So in this tutorial we will be learning how to find the square roots. That is, if 144 is given in the question, our answer will be 12. That is, we have to find that number which when multiplied by itself gave 144. Here we can pretty well see the numbers which when multiplied by itself gives the perfect square. But there are certain numbers, or whenever it comes in the form of a question, then just by seeing we cannot say which are the square roots. So we have to follow certain processes for that. We will learn those processes in this tutorial. The first process which we are going to learn to find out square roots is the factorization method. Here, when a number is given to us, we find the square root of that number using the factorization method. This is a comparatively easier method, but in maths almost all the methods in each and every topic has got certain pros and cons. So factorization method is applicable, or I should say factorization method could be applied in a good way for smaller numbers or the numbers whose factors we can easily understand by seeing. Let's take an example. Suppose we want to find the square root of 441. Now to find the square root of 441 by factorization method, what do we have to do? So we draw a grid like this and we have to go on dividing 441 by certain numbers. Which numbers? Which are factors of 441. Now let's see, 441 is not an even number because 1 is there in the ones digit, so it cannot be divided by 2. What about division by 3? Let's try the divisibility test of 3, that is adding the digits. So 4 and 4 is 8, 8 and 1 is 9. So 9 is a multiple of 3. That means 441 is divisible by 3. So we can divide by 3. So let's do it. 3 into which number gives 441? That number we have to write here. Now it's best when you do this kind of divisions mentally, but if you face problems you can do it by drawing a rough column. So let's do it. 3 into 1 is 3, so we get 14. Now 3 into 4 is 12, so we get 21. So 3 7 times is 21. I have done it mentally. If you develop this practice of doing it mentally, it will be easy for you. Otherwise you can do it by division as well. Now we get 147. So again we continue with this grid. Now 147 is a number. Again we cannot be divided by 2. So let's try again the divisibility test of 3. 1 plus 4 is 5. 5 and 7 is 12. Yes, 12 is a multiple of 3. So 147 can be divided by 3. So let's try 3 once again. 3 4 times is 12, 27. 3 9 times is 27. So we are left with 49. Now 49 is actually 7 into 7. So 7 times 7 is 49. And according to the rule, we should stop the process by 7 into 1 is 7. So whenever a 1 comes here, the process stops. So we get 441 as 3 into 3 into 7 into 7. So let's write 441 equals 3 times 3 times 7 times 7. Now the problem is to find the square root of 441. So this is the square root symbol, square root of 441. Whenever we do the square root, we have to remember out of these pairs we have to take out one number. So we see we have got a pair of 2 3s over here, we have got a pair of 2 7s over here. So out of this pair, that is 2 3s are there, so we take out 1 3, and out of these 2 7s we take out 1 7. So pairing them is important. Whenever we are writing the number in this product form, you have to write it using pairs, so that we can easily take out one number from each pair. So 3 into 3 into 7 into 7, so we take out 3 and 7, that is 21. So square root of 441 is 21, or in other words 21 multiplied by itself will give you 441. So this is one example which I have shown using the factorization method. Let me show you another example using the factorization method. Now let's try 625. So we draw a grid like this. Now we have 5 in the ones digit, so we can pretty well say that this can be divided by 5. So let's try 5 1 time, 2 times 10, 25, 125. So we are left with 125. Again 5 comes here in the ones digit, so we can again divide by 5. 2 times is 10, 25, 5. And now this time it will be 5 into 5, and finally we are left with 5 times 1. So 1 comes and we stop the process. So in the same way we will write 625 equals 5 times 5 times 5 times 5. So we see we get 2 pairs here. So therefore square root of 625 will be, as is the rule, we take out one number from each pair. So 5 from here and 5 from here. So that is 25. So our answer is 25. That is 25 is the number which when multiplied with itself gives 625. Now this is a pretty easy way, but this process has also got some cons. Like for very big numbers, if we try to go on dividing like this, it will be a very long process. It will be a lengthy process. It will take a lot of time. And one more con is there, that is here by seeing the number we can understand by which number we have to divide. That is, by applying certain divisibility tests we can do that. But I've got certain other numbers, like for example 1369. Okay, now by seeing this number or by applying any divisibility test, it is not possible to find out a factor of 1369 quite easily. So in that case factorization method is not a good idea. So we have to learn the other method, which is called the division method of finding square roots. So let's move on to that. We will learn the division method of finding square roots. So we come to the next part, which is learning the division method of finding square root. Now as the first example, I'll take the last number which I left in the previous example, that is finding the square root of 1369. Now this is also an easy process, but we have to be very careful about certain points which I am going to tell you in this tutorial. The first thing is, in the division method, we have to put dots on top of the numbers starting from the rightmost number, that is the ones digit. So the first dot we put on top of 9, then alternatively we put dots, that is we leave 6 and put a dot on top of 3. Then we have alternatively, if we go on, we are left with no other number, so we stop here. So 2 dots are put. Remember, we always have to start from the right hand side. The first right hand side number, that is the ones digit, will always have a dot. Then alternatively we have to put dots on the other numbers. Now as we do in the division sign, in the division process, we draw a symbol like this, and now you have to pay attention over here. We have got 13. You have to look up to the first dot, that is 13. Now we have to think of a perfect square which is equal to 13 or just less than 13. Now as we can see, 13 itself is not a perfect square. Now how do we understand which are perfect squares or not? In the middle of the process, let me tell you, numbers ending with 0, 1, 4, 5, 6 and 9, the numbers which end with these digits, either of digits, may be a perfect square. Like 1, 3, 6, 9, we see 9 is here, so 9 is there in this list, so the numbers ending in these, either of these digits, may be a perfect square. Now so the other numbers, that is the numbers ending with 2, 3, 7, 8, will never be perfect squares. Okay, please remember this small rule. Anyway, so let's come back to the process. So we are first concerned about 13. So let's try to find out a perfect square which is just less than 13, because 13 itself is not a perfect square. So that is 9, and we know that 3 square is 9, so 3 3s are 9. So we have to write 3 over here, the number whose square is 9, that we have to write here. That is the square root of 9 we have to write here. So 3 square gives us 9, and then we subtract. So 13 minus 9 gives 4. Okay, now we draw a sign like this facing this side, and we have to do twice of this number, that is 3 into 2, that is 6. Every time we have to do twice of this number. And one more thing to be taken care of over here, please leave one space to write one digit over here. Okay, so this is the process. Let me just repeat the last few things. We get 13 minus 9 is 4, then we write 3 2 times, that is 6 over here, but we must leave a space for one digit which we will be writing over here. Now we see 4 has come here, so which is not sufficient for the division to proceed. So we bring the number up to the next dot, that is 469. So the up to the next dot is 9, so 469 comes here. Now we have to think of this digit, mind it, we have to think of this digit which will be multiplied with this digit which will be same. That is, if I think of 1 over here, so 1 should come here also. If I think of 2 over here, so 2 should come here also. So that is the rule. Now how will we understand? We have to look at this number 469, and 60 what into what will give this. Okay, if I say 67 into 7, how did we understand? 7 into 7 gives 49, so there's a 9 in the units digit. We could have also done 63 into 3, but that would be too small a number. So 67 here into 7, so we have to multiply 67 with 7. So that gives us 7 7s are 49, 4 carried, 7 6 are 42 plus 4, 469. And the remainder is 0. So this point has to be taken care of. The digit which we write here, the same digit has to be written here, and this full number has to be multiplied with this digit. Okay, it might happen that this is not exactly divisible. Then in some other cases we might find the division proceeds. Okay, it doesn't end here, just as we do in simple division of numbers. So square root of 1369 is nothing but 37. Okay, to make the concept clear, we will move on to another example. So here we are with another example, that is 91,204. Now the same process as I showed in the last example will be followed here as well. So we first start by putting dots from the right hand side. So a dot will be there on top of 4, we'll leave a digit, a dot will be there on top of 2, we'll leave a digit, a dot will be there on top of 9. Then we proceed as usual. Now 9 is a perfect square because 3 square is 9. So 3 square is 9. So this is the first part, and we write 3 into 2. Every time we have to do twice of whatever we get here. So 3 into 2, that is 6, keeping in mind that we have to leave a space for another digit over here. Okay, so we bring down 12. Now what could be the smallest number here, smallest natural number? That could be 1. So 61 into 1 would give us 61, but that is much greater than 12. So let's try with 60 into 0. As I told you, whichever digit will come here, the same digit should come here. So 60 into 0 is 0. So we are left with 12. Now 30 has come here, we have to do twice of 30. The same rule, again we have to do 2 times of 30. So that is 60 over here. Again we leave a space, right? Now as I told you, up to the next dot the digits should come down. So it is 1204. Now here again the same rule, we have to find out one digit which will be written here as well, so that the whole number into that same digit will give this. Now had it been 601 into 1, that is 601 into 1, that would have been 601. Let's try 602 into 2, that is 602 into 2. So that gives 602 into 2 is like this. Yes, we get 1204 and the remainder is 0. So I'm writing here square root of 91,204, that is 302. Okay, one point must be kept in mind: whenever we find square root of a positive integer, the answer which comes, that should have both the signs, plus and minus. But I'm not talking about the negative sign now, because that is beyond the scope of this tutorial. Maybe in some other tutorial I'll discuss about that. So I'm writing only the positive part. So square root of 91,204 equals to 302. So this is actually the process. This process is summed up over here, but I will try to give you now some special examples where you can eliminate the workload of doing such a long thing. I've taken another example over here, that is 3,84,400. We have to find the square root of this number. Now see, whenever we get an even number of zeros in the end, so here are 2 zeros, so in that case we can simplify the problem. That is, instead of finding the square root of this whole number which is given here, we just find the square root of 3844. But we have to keep in mind, while writing the answer, we have to put one more 0 at the end, because we are skipping this part over here. So we just find the square root of 3844. The same process, we put a dot on top of 4, a dot on top of 8. Now we find the nearest perfect square, which is just less than 38. So that is 36. So 6 square is 36. And we get 6 times 2 is 12, keeping a space over here. Now we do the subtraction, 8 minus 6, that gives us 2, and 44 comes down. As I told you, up to the next dot the digit should come down, that is 244. So I think by this time it is pretty clear to you that 2 will come here, because 122 into this 2, the same digit, 122 into 2, that is 244, and the division process ends here. Okay, so square root of 3844 is 62, but the question was square root of 384400, that is 3,84,400. so 3,84,400, square root of that would be 62 first, and then we put 10, because the factor of 100 is there, which is 10 into 10, so 110 comes out, so we have 10 over here. Now this is true only if we have an even number of zeros in the end. So suppose we had 3 zeros over here, and somebody asked us to find the square root of this number, then this whole process wouldn't have been applied, then we have to find out the square root of this whole thing. Okay, but in case of 3 zeros, suppose we had 4 zeros, then also it becomes very simple. We do the same thing, and in case of we just put 2 zeros over here, so in the answer we have to add 2 more zeros, that is 4 zeros in the question, so 2 zeros in the answer. So we just simplify the problem like that. But please keep in mind, this is true only for even number of zeros, and that too at the end of the number, nowhere else. Now I'll be showing you how to find square roots of non-perfect squares. Now we are here with the number 135, which is not a perfect square. So let's see how to find the square root of this. Now let me tell you in the beginning, the square root of this number will be an irrational number, that is a non-recurring, non-terminating decimal, so the process will never end. So I will not show you the full process, because that would be an eternal process, so I'm not going to show you that, but I will just show you how to proceed with this kind of numbers up to certain steps. So we put a dot over here, we put a dot over here. Now the same rule applies, that is 1 square is 1, then 1 into 2 is 2, keeping a space over here. Now we bring here 35. Now we see, if I put 21 into 1, 21 into 1, that would give 21. Okay, if I would have put 22 into 22, that would have been 44, which would have been greater than 35, so I'm not doing that. So we are left with this, and we do the subtraction, 14. Now there are no more digits to be brought down, so what we do is we put a point and bring 2 zeros over here. This is a rule which must be remembered, a bit different from general division. In general division, with 1.10 can be allotted, but here in case of finding square root, with 1 point we bring 2 zeros. Now 11 was here, so 11 into 2, that is 22. Again the same thing, we have to look out for a number. 22 into 220 something into that same something will give a number very close to 1400. So let's look for that number. Now we see, if we do here 227 into 7, so 227 into 7 would give us a product which would be greater than 1400, because 227 into 7, we see 7 into 2 is already 14, so the whole thing must be greater than 1400. So let's try with 226 into 6, that is, let's try with this 226 into 6. So let's do that. So we get 1356. Now again we do the subtraction over here. 6 to 10 is 4, 5 to 10 is 6 to 10 is 4. Yes, we are left with 44. Now 116 times 2. Now to consider the whole thing ignoring the decimal point. So 116 times 2 is 232. Again the same thing, we'll bring 2 zeros because we have already got 1 point. We can bring 2 zeros over here. Now let's try to think of the next number. Now we see that if we multiply 232, we have already got 2322 if we write here 2, so we have to write here 2 also. So 2322 times 2 would give us this 2644, I'm sorry, 4644, which is greater than this. So it would be 2321 into 1, that is 2321. Now we do the subtraction. 1 to 10 is 9, 1 plus 2 is 3, 3 to 10 is 7, plus 6 4, that is 0 and 2. So now 1161 into 2 would have come over here. The same process would have continued. So I am not continuing with that, because as I told you, this would be an eternally long process. So in these kind of questions, it might be asked, find the square root of 135 up to 1 decimal place or up to 2 decimal places. So you have to do like that in this case. Okay. So that's it for today's tutorial. We did quite a lot of sums, and we learned two processes. One is the factorization process, the factorization method, and the other is the division method of finding square root. Hope all of you have enjoyed this tutorial. If you have any questions or any doubts or any queries, don't forget to write in the comment section below. I'll try my best to answer them, and do practice this kind of sums. Let me tell you in the end of the video that these are not the only two processes to find square roots. We have got wonderful methods of finding square roots in the Vedic mathematics system. So maybe I'll discuss that in some other video. For today, let it be up to this. I hope you liked my video, and if you really like my video, do press the like button and share my videos, and don't forget to subscribe to my channel and press the bell icon. Have a nice day. Bye to all of you.